thanks for the invitation. This has been fun already for me this morning. It's sort of like old Friends Week, but that's before I can report it. Just a wonderful opportunity. And then I was reminded, which I had totally blanked out by Kim Moss, that apparently I had interviewed at Emory early in my career. It was long gone in the ether of the past. But interestingly, coincidentally, it was right before I made the transition from psychoneuroendocrinology to psychoneuroimmunology. So maybe it was all destiny and part of a plan to enable me to give this presentation today, where I had once been, which was hormones and behavior, which was similar kinds of work in many ways, but now focused on the immune system as the outcome, which sometimes involves hormone mediation. I should say in passing to the students in the room, that this is the kind of presentation that is potentially dangerous to your career plans. Because it was a talk like this around that time, in fact, back in the late 1970s, early 80s, I had heard a presentation on the possibility that one could condition the immune system. This was the work of the late Bob Bader, who had done some, and continued to do for all of his career, studies documenting that you could condition immune responses to both go up or down just by pairing some type of stimulus with an immunosuppressive or immune-enhancing drug. And to this day, we don't fully understand how that comes to pass, but it is definitely true, even to the point of reducing the immune response to a transplanted organ like a heart. The ability to reject the heart or not, you can condition that. And so that's a part of psychoneuroimmunology, which is one of the presentations about. In putting this talk together, I guess I may have misgauged a little bit the audience. I thought it was going to be people who wouldn't want to hear too much about my monkey research. So I actually don't have much on primates until the very end. Another career transition for me happened about 15 years ago when I began getting more and more immune studies into the types of projects we did. And so most of this presentation is actually on the immune research, and only in the very tail end that I'll get back to what we study in monkeys. But along the way, since I realized this is a mixed group, some people can grow in some primate models, just sticking verbally at least how one would translate from humans back to animals, translation relevance going in that direction. So the game plan is, again, I know it's a mixed audience and some people might need some backfill. So the first 15 minutes or so is going to be just the framework of PNI, what is PNI, what are some of the general principles, which is similar to psychoneuroimmunology. I will use some of my own work and a few findings from others to give some exemplary findings of what it's like if you do a PNI study in terms of how the immune system can change up or down. And then, assuming I don't run out of time or you don't ask questions, feel free to ask questions. I'm an undergrad teacher, I'm used to juggling view. And there are multiple endings, we don't have to get to the end. But if we do get to the end, I'll touch a little bit on the relevance of PNI to asthma and inflammation. I've done work on chronic pain disorders, so I'll talk some about the link between pain and immunity. I'll show some current work we're doing on cancer biology, just to bring it up to today. And again, if I make it to the end, then I will segue to work with primates, pregnancy, early infancy, on the relevance of PNI to maternal and child health. So that's the game plan. Again, real deep background now for somebody who's not used to thinking about this. I didn't know how mixed the audience would be. Psychology has something to do with biology, something to do with health, real deep background. But if you're not used to thinking about health side of behavioral medicine, we know that a person's lifestyle, aspects of their behavior, even their thought, their emotions can impinge upon our basic physiology. I said that with regard to cardiovascular function or blood pressure, that would not be very new. I think personality, high blood pressure, hypertension, that's controversial. I said anxiety, irritable bowel syndrome, not controversial. In the early days of P&I, though, it was very controversial to say, and the same is also true for the immune system. It was considered, the immunologists didn't like the idea, it was thought of as a much more autonomous system, much more important. How could the brain possibly, how could behavior possibly influence something so critical to health and well-being as an immune response? The field coalesced in the early 80s. It's got a name. There was some controversy about what name to give the field. People wanted to have different names in the name. I think the name that most of us use today is the one that stuck, Psychoneuroimmunology. The idea that there's some relationship between behavior through the brain to the immune system, the link to the nervous system, to the immune, and it has some far-reaching relevance beyond that, which is that it addresses how these three systems communicate with one another. Back in the late 1800s, early 1900s, we sort of created these three systems. We studied them as if they were independent of one another, nervous, endocrine, immune. In truth, there are extensive interactions, hormones influence immunity. Your autonomic nervous system influences immunity, regulates immunity, and conversely, there is bidirectional feedback from immunity back to brain. So in a real way, in a sort of holistic medicine way, what psychoneuroimmunology is doing is putting the body back together. So that's another way of thinking about it, which is it's integrated physiology, systems physiology. So for someone who likes that, students, it's a great field. I was happy that I made the switch. It was controversial in the beginning, and this is an ancient flow diagram of mine going back to the 80s, because this was thought of as mysterious. When I first got to Wisconsin, I was introduced as the chairman of medicine, and he said, "Oh, you work in that field of voodoo medicine." That's how it was thought of back at the beginning. And this was a flow diagram I had put together so it didn't seem so mysterious, how it was possible an event in the outside world, through perception, through the brain, was able to impinge upon each all the way down to cell functions. And the purpose of this flow diagram was to say, well, it's really not that mysterious. It's through all the pathways that we understand pretty well, which is hypothalamus to the neuroendocrine axis, hypothalamus to the autonomic nervous system, sympathetic, and that's not controversial. It's not controversial to say that cortisol can affect immunity, or that adrenaline or noradrenaline can affect immunity. Nor is it controversial to say that you can obviate, you can make all of this go away, simply with a behavioral response. Psychologists call it coping. Show a predator to a prey animal, you're going to elicit this response. Let the animal move 10 feet away from the predator, coping, and you won't see any of this physiological change anymore. Again, it shouldn't have been controversial, but it was. For those of you who know the history of the stress field, this is the father of stress, Hans Selye. Back in the 1930s, he defined the stress response, the general adaptation syndrome, 1930s. Most people remember that as cortisol corticosterone, but if you're familiar with this area, he actually had the immune system already built into the stress response. There was a triadic response, hormone, gut, and immunity. Back then, they didn't understand immunity as well. They couldn't measure it as well. But he included as one of the three criteria of the stress state, lymphatic involution, the shrinking of the thymus and lymph nodes. Back then, they had to just weigh them. But he also already was aware that there were changes in cell numbers. He commented on the fact that lymphocytes went down, neutrophils went up, the eosinophil disappeared from circulation. In fact, if you're a Catholic, the biblical, the strict interpretation, you should not say an animal is stressed or a person is stressed unless you can also document an immune change, because it was part of the triadic response. It's not just cortisol, corticosterol, and there also needs to be shrinkage of the lymph nodes or thymus, or today, as you'll see, pretty much about it. Part of the problem was, in this thinking, was it was too simplistic. Back then, in his view, it was simple immune suppression. Today, we realize immune responses not only go down, they go up, and in this response, in fact, it's dynamic. Some are going down, some are going up. Pro-inflammatory responses tend to go up, while other responses go down. Today, as a consequence, I have to make a much more messy slide, and the purpose of this is just to convey to you there's a lot that we now know. A variety of human adverse events, school exams, divorce, unhappy marriages, unemployment, caregiver burden, all of these have been shown to influence immunity as a part of the PNI, and they're an equivalent set in animals: novelty, aggression, intrusive paradigms, pain, restraint, mobilization, early separation, show an animal predator, you can show, just put the animal in the presence of the human, the predator, all of them induce immune responses, and we now know that the effects span all types of immunity. What's spoken of as innate immunity, complement, neutrophil function, those tend to actually be activated, at least acutely, by stress. Cell-mediated immunity, wound repair, tumor surveillance, control of latent herpes viruses, those tend to go down. Adaptive immunity, ability of vaccines to work, regulation of T cells, all of these in one way or another can be affected by every one of those events. And increasingly we've become aware that it's not just something in vitro that you measure in the lab, but you can actually show that there are some clinical consequences in terms of risk of infection, pro-inflammatory bias, increasing inflammatory disorders, slow wound healing, old age, immune senescence, it pushes an old host towards immune senescence, and the ability to detect the malignancy and or to control it may be impaired as well. Early on, the field struggled with showing that these changes we could document in the lab actually meant something. This was one of the first, for me, findings where they were able to say, this is a change that actually matters in the real world, matters to the clinician. It's still a challenge that they push us on and say, show me that it really has clinical significance. It's not just basic science. This was a study by Jan Glazier and our husband Juan Glazier. They were studying older people who were care providers for spouses with Alzheimer's, and it was an elegantly simple study. They just put a small wound biopsy onto the arm.
Of the person, of the caregiver, or?
Oh, caregiver. This caregiver's dressed up. Please feel free to interrupt me along the way or ask a question with something not clear. This was caregivers, care providers, and there were age-matched, gender-matched controls, and they're looking at how many weeks, and these are old people, so it actually takes quite a few weeks for some of them to just repair, to heal over this small biopsy site. As you can see, some 4, 5, 6, 7, 2 months out, they're first beginning to heal over the biopsy site, and as illustrated in the red, the ones who are experiencing caregiver stress take significantly longer, on average 9 days longer, than the people who are age-matched controls. That may not sound like immunity, but what they demonstrated next was that the explanation for this is whether you control bacteria that come into the wound site in the first day or so, and the speed at which macrophages and monocytes are initiating tissue repair. That actually is what accounts for this.
I was just looking to ask something that you kind of answered that, actually I was just concerned. Caregivers obviously have a lot on their plate. They might not have time to take care of themselves occasionally. And I was wondering how they controlled for that. But you just specified.
Yeah, they went on to do more basic pathway studies to explain what. And I should also say this same effects happens in rodent models, or people to this day studying exactly what are the mediating pathways that explain why wound repair is slower in a stressed host, be it human or an animal. And it's down to the level of how fast can the neutrophil get to the site to control the bacteria, which bacteria become established, how fast the monocytes and macrophages get there and initiate the tissue repair wound process.
Has anyone looked at whether pharmacological intervention with benzodiazepines for the stress has an effect on wound healing?
I would imagine it does, as long as benzodiazepines don't interfere with the basic biology related to tissue repair. I often get asked that with my animal studies. They say, can't you do something? I'm so thrilled to get a graph to show the effect, and now you want me to make it go away. My guess is yes, if you somehow at the level of what is stress perception, lessen it, antidepressants, anxiolytics, yeah, I would think that the cascade going downwards would tend to be lessened or entirely blunted and ameliorated. That's sort of like my little coping arrow, that if you do something along the way, I mean, I teach an undergraduate class on stress, and so I usually say, what is stress? It's what you perceive to be stressful, and then the rest is the downstream. So yeah, I would imagine anxiolytics, antidepressants would be effective. This kind of basic biology, this idea is relevant to all of us, even as we sit here, even those of us who are young and healthy. I usually then go on to say, I think PNI is even more relevant to people who have some sort of ailment that involves the immune system. So all of this is true for us, and I'll show you what happens to undergrads during final exam week. But I think it takes on a particular significance if you're already immune compromised or challenged for some other reason. So I think it has particular relevance to skin diseases, psoriasis. It's relevant to autoimmune. So if somebody has MS, multiple sclerosis, rheumatoid arthritis, that goes with autoimmune disorders, I think this takes on added significance, and as we're going to appreciate, it has particular significance to cancer control and progression and recovery. I'll show you one example of that work we're doing. It's grown in the last 5 years as we've come to appreciate the linkage between immunity and inflammation, and have gotten better at having biomarkers of pro-inflammatory bias in the blood, and the realization that cardiovascular disease has an inflammatory component, diabetes has an inflammatory component, most gut disorders, Crohn's, ulcerative colitis has an inflammatory component. So now if I start to say, oh, stress has a pro-inflammatory influence, one can sort of begin to bridge to other conditions beyond the ones that are strictly immune-related diseases. A lot of this research, for those who've been paying attention to interleukin-6 in this area, one of the common measures to use in blood is IL-6. Starts out as something immune-related, but now we realize it's related to obesity, cardiovascular disease, aging, bone loss, Alzheimer's, including up in the brain. And it's really easy to show that IL-6 changes with stress. And of course, people, I'll just give one example. You mentioned the MIDAS project. MIDAS is a survey of health in America, which I participated in. It's really a survey of health and aging in America. And it has a sister project, which we do in Japan, called Midlife in Japan. And this is IL-6. We can look at this graph first, comparing Japanese to Americans, Caucasian Americans to African Americans, and all you're looking at for 1,400 people in America, 400 in Japan, is IL-6 levels for men and women, and you see First, there are national differences. Americans have much higher IL-6 than do Japanese. Embeddedness are also effects of aging. IL-6 tends to go up. IL-6 tends to be higher in overweight people. As you know, there are a lot of plus-size Americans these days. And so when I publish this, the first thing the reviewer says, oh, it's all obesity. And so the media actually show the same data after you take out any American who has a BMI over 30, but in fact it doesn't go away. Something about the way we live beyond the fact that we tend to be overweight. So everybody who had a BMI over 30 is taken out, but you can see we're still left with a race difference and a national difference. We're eating sushi for lunch, good idea. There's something about the American diet, the American lifestyle, and there's more embedded in this. We know that anger influences, as we've done those analyses, discrimination, SES influences, and then on the positive side, psychological well-being. All of that accounts for some of these differences between national and racial. But it's that simple. We can just, if we can go around the room, some of us in this room have IL-6 over 3, hypograms per mil, and we don't want that. We really want to be down here about 1 or 2. Ideal. And then it tends to go up with age, and there are lots of reasons why you see changes. As important as the discovery, I think, and maybe even more important, was it's not just downstream, it's not just psychology of the brain, down to immunity. There's an equally important signaling, which is going back up from the immune system to the brain. And some people in the field of PNI just studied that. Study how does immune activation influence brain and mood, fatigue, and it led to what I would say is one of the great discoveries of the field of PNI, which is cytokine-induced sickness behavior. The idea that when you have high levels of cytokines, not just IL-6, other cytokines as well, it induces a fever, but it induces more than that. It induces a whole concatenated syndrome, which used to be thought of as separate, but it really is a syndrome, a constellation, which is malaise, loss of appetite, social withdrawal, loss of libido, and an inability to learn. Anyone who's that day before you get sick, you know, you just lose interest, withdrawal. And what some people, including, let's see Andy here, Andy Miller was a big player in this, the linkage between this type of biology and response and psychiatric depression. Back in the 90s, I used to do studies where I would take monkeys and I'd inject them with interleukin-1. And I could take a perfectly healthy, fine animal, and 15 minutes after I injected it with L1, it looked, it had this syndrome. It couldn't learn, it was curled in the wall. It's that fast that you can take an animal, a host, and go from this state to that state with a jolt of IL-1 or endotoxin. And this, I didn't know if Andy was going here, so I took one Andy's slide. And it just led to what I would say is one of the next most important demonstrations that this is not just basic science, but has clinical applicability. For a number of conditions, people take immunomodulatory substances. In the case of Andy's research, they take interferon for hepatitis, and he documented that when people are on interferon, another cytokine, for several weeks, they will often become depressed. That's this line here. What's the likelihood that they become depressed on the weeks of interferon therapy? And a fair number of people become depressed, and he demonstrated that something prophylactic, that a pre-treatment with an antidepressant can prevent this depressive response. And in truth, probably most people who are going to go on interferon or some other immunomodulatory therapy like this, it might be advisable that they prophylactically, in anticipation, go on antidepressant drugs. That's your stuff. That's Emory's paper, so I don't have to say more about that. It gets challenging to work in this area because there really isn't one immune system. Well, there's one immune system, there's not one immunity. You really have to become interested in immune responses at different parts of the body, because the immune system works everywhere. And there are different cells to study, many, many different types of cytokines. And so for anyone interested in this area, you do have to spend the time to, for any student I've just convinced to switch career trajectory, you do have to spend some time learning immunology if you want to be able to compete in this field. Many different ways of studying immunity. This was a doctoral thesis project of Duffy Tang, stayed in the field of P&I, and what she was studying was two types of immune responses. This was back when we did things in vitro, and she was studying how natural killer cells and neutrophils change during life stress, and the life stressor she was studying was school exams, and she followed 135 high school kids through final exam week. Afterwards, measuring cellular response, same with college kids, we've done in college, and same with med students. This is what the assay looks like. You take the person's white blood cells, separate them on nuclear cells, and then you put those cells in with a target. In this illustration, it's a cancer cell, but it could be a viral transform cell. And if these are lymphocytes, this is your target. The assay is simply measuring lysis. How good are these cells to notice that's a mutagenic cell? How good are they at opening a hole in the lysis? That's the assay. And this is what it looks like if you do this in students. We can do for college students as well. So high school kids, on average, there's a 40% to 50% drop in NK activity, killing ability. This is pretty standard, and it takes a couple of weeks to recover. Psychologically, there are individual differences. Some go down more, some go down less. To the degree to which they tell you they feel lonely, to the degree to which they tell you they feel they have a discrepant cognitive style, they go down more. Females go down more than guys. You can study how much do they go down and why, in addition to the exam itself. I'll get back to that in a second. One of the more interesting ways we studied this was to try to link it up with brain activity, and I worked with a colleague of my opponent, Richie Davidson, because we were interested in predisposing factors to who would go down more. And if you're familiar with Richie's model, it's based on frontal brain asymmetry and activation patterns. And if you're more activated in the left frontal pole, you tend to be a happier person, you tend to approach. Whereas if you are more activated in the right frontal cortex, you tend to have a more negative affective style, and it's associated with withdrawal. And if we went around the room, we would each vary a little bit, plus each of us can change state-wise. This was done in college students, 35 college students. We took a blood sample in October, which was a non-test time, did EEG to screen them for individual differences, sorted them into those who were more left frontal activated or right frontal activated, followed them into exam week, the same paradigm, and what you can see is everyone's going to go down a little, but the right activated person who they were in October predicted how much they could go down in December during individual differences in vulnerability, and then you see you can come back up. Let me turn to this other graph. Same people, same blood, different cell type. We're setting up this assay over here, the NKs go down, and this, I should say this would be true if you did a monkey study. Take a monkey out of a social group, I've done them, put it into an individual cage, you'll get this graph. NK activity goes down. You would also get this graph. I've done this in monkeys too. Simultaneously with this immunosuppressive effect on some cell functions, others turn on. Innate immunity tends to be turned on by stress. Pro-inflammatory responses turn on. Neutrophil function turns on. In this case, the measure is how much superoxide they release. That's normally what you would do to respond to a bacteria. I used to say, it's almost as if school exams are like getting a bacterial infection. That was how I used to spin it and think. Now I realize, and there are a lot of studies to support this, that it's actually maybe not just like a bacterial infection. Increasing evidence suggests that we're responding to the gut microbiome, endotoxin, and even bacteria may be translocating. And so it may not just be like a bacterial infection, there may actually be some true bacterial stimulation to account for this. And this is dramatic, and what's amazing about this, even 2 weeks after school exams, and this is solid, with 135 kids in this, even 2 weeks after final exams, these neutrophils are still harmed. And this happens and it goes along with cell homogenation. If you've ever done that, that's done a CBC, lymphocytes drop, and it goes to a lot of bacterial infection and stress. In monkeys, sometimes in some stressors, I've had them 90% neutrophils. If you keep the stress up. So at the time I became interested in, well, what would happen if you took a host, an individual who was now in this altered, dysregulated state from stress, and challenged them in some way, or what would it be relevant to with a clinical condition? And I hooked up with an allergist on campus, Bill Bussey, and we applied this thinking to asthma. So we're segueing now to the first of the clinical conditions. So if you're in this altered, dysregulated state, and now you're exposed to an allergen, you would predict there would be a different reaction, and that was exactly the study we did. This was done with college students now, 20 kids with allergic asthma. We screened them to verify that they actually had allergies, allergic asthma. We did skin testing to determine what they were allergic to, ragweed, catgut, or dust mite, and then, this was an amazing study, we asked them to inhale what they were allergic to during the final exam, and induced a mild asthmatic attack, dropped it and fixed it. I shouldn't say that to my IRB. What we did at the IRB approved it. And actually, then they had to sit for 24 hours in the pulmonary. This was serious. They could actually forecast that. Plus, we were monitoring them for 24 hours. But to be honest, we didn't do it on the day of the test of this exam. I have another funny story about that. So there's an inhalant challenge, and the kids came back. They did it once during the exam week, once during part of the semester that weren't taking the test, and it's counterbalance. 10 kids did exams first, then the non-testifying counterbalance the other way. The other thought that was important about this is now we stop measuring blood cells. We actually were doing cells from the airways. That was another invasive part of this. They actually inhaled liquid and brought back up sputum, which we did in the assays. And we did a variety of measures. The most important part is shown here, which is when we took the cells from the sputum that they had brought up, took the cells in culture, the cells during the exam week were really primed to respond. We were measuring the different cytokine relevant to asthma, interleukin 5, and as you can see, over the 24 hours after we induced this response, but especially exam week, now these cells were just primed to turn out interleukin 5. And the reason why we focused on that cytokine is that cytokine's role is to call eosinophils. It induces an active response. And so we were actually counting eosinophils come into the airways. And as you can see, it was a high percent. So during the exam week, there was a significantly greater number of percent of eosinophils called into the airway. And it led to what I call a stress diathesis model. Everybody when stress shows an immune change, all kids during the exam week show immune changes, but that normally resolves without any consequence. If they happen to be allergic, and they're exposed to an allergen in that state, now you get the synergy, the vulnerability diathesis model, resulting in a larger cytokine response in the case of asthma, call in the loop sites to the airways, which you don't want because they're associated with airway inflammation. Stress is pro-inflammatory. Because if stress was simply immune suppressive, you might actually say, well, isn't that a good thing for asthma? You would actually expect, this was a way to explain why stress aggravates asthma as opposed to helps. It helps in autoimmune. Why does stress make the autoimmune process worse because of that? Pain. You're going to work away. This goes to one. We're not stopping me, so we actually don't get through this. I apologize for those if this is a little bit too much of a smorgasbord, but I figured not everybody would have an equal interest in this topic. Given what you've heard so far, it's not surprising that pain would have an effect on the immune system as well, and it does. It affects cytokines, and it results in pain sensitization. It's thought that cytokine and inflammatory processes can influence pain processing at every level, out of the periphery, inflammation, the firing of sensory neurons, processing at the level of the dorsal horn, going up to brainstem, influencing the monoamine response, sensory gating or not, on up into the brain, microglia, astroglia activation. Cytokines are present at each of these sites and can influence what happens and whether or not the pain signal gets through or not, larger or smaller. How simple is it to demonstrate this? Well, relatively simple, provided you can find participants who are willing to have hot peppers injected into their muscle or capsaicin. So capsaicin injected IM into person. It makes you don't even have to do that. It's good. You probably have an IL-6 response. Sitting there a couple hours later, you can use an increase in IL-6 in the bloodstream. Not surprising, your pain response. How long have we known about this? Forever. We go back to the proverbial Greeks and Romans. Those of you who have a little experience or know the cardinal signs, galore, galore, or in English, pain, redness, warmth, swelling, cytokines. I mean, every one of the cardinal signs is at least in part driven by cytokines. Back then, they used to speak about it as body humors. Today, I'm just saying it's cytokines or anti-cytokines. Once you become interested in this, you realize there's not just one cytokine. There aren't even just 6. There are up to several dozen of these cytokines now. And what's a cytokine and what's a hormone is not always so clear anymore. But if you become interested in pain in this area, you do have to pay attention to the fact that there are some cytokines that are pro-inflammatory, like IL-1, TNF, and IL-6, and there are some that have more of an anti-inflammatory effect. So there's a yin-yang component. So this was from some research we were doing on people with chronic pain disorders. So you can get chronic pain in a number of different ways. We were studying people with neuropathic pain, which involves real changes in nerve tissue, nerve damage, loss. And we were also comparing them to people who have a more enigmatic type of chronic pain disorder, fibromyalgia, where part of the diagnosis is we can't explain it. And what you can see here, if you simply take a blood sample from people with these 2 chronic pain disorders, and it was interesting that the fibromyalgia people in particular had low levels of this anti-inflammatory cytokine. This is just neuropathic pain patients. It even helps to explain symptom severity. So in this case, every one of these dots is a patient. They all have neuropathic pain, but they report different levels. And if you really with pain research, they will use visual analog scale. Probably remember some disorders. How much pain do you feel on a 1 to 10 scale? And that's just portrayed here. These are patients. They all have neuropathic pain. And in this case, we were taking CSF because we wanted to know about size. We were talking about CSF. This was that mesoscale discovery we were talking about before. And what you can see is the more the patients who have said they felt pain, unbearable pain, they can't stand it, the more the IL-1 was high in CSF, and this was the blood measure of IL-10, the lower was their IL-10. And so the thought is, if you have a person with chronic pain and there's this imbalance of the pro and the anti-inflammatory, that might improve the separation. There are many different ways of assessing immunity. The simplest buy-in, the simplest way to go is you get a blood sample or CSF or something, and you measure a cytokine. That's one way to go. It's more elegant these days to do some type of characterization of the cells, and we've come a long way from cellular and neutrophils and lymphocytes. Now you can do amazing immunophenotyping, and this was one that I became interested in. Could chronic pain affect these cell populations, monocytes, AT cells, and NK cells? I'll just illustrate this with one graphic to show how you do this, if this is not familiar. So I take a blood sample from this nice guy here. I take 10,000 of the cells, I run them down a fax machine with monoclonal antibodies, and you can do this, then you can sort the populations, this scatter of cells. These are the monocytes, but you can do more than this. You can do as much as you care to know these days. You can separate the monocytes into less mature, more differentiated. You can take them a little further and say, oh, I'm interested in markers on those cells. It's that slick. In this case, we were interested in this marker, ICAM, on that population. A lot more than I could do in the 80s when I first started. Back then, there were lymphocytes or B&T cells. This is a great time to get into the And if you do that, you end up with something like this, which is that the neuropathic pain patients in this study, they show more, based on the cells, more of pro-inflammatory activated cells in the periphery, more activated monocytes expressing this ICAM. And I came away, just to give you the take home from this, I view neuropathic pain as more of an inflammatory disorder. Fibromyalgia still is enigmatic to me, and it's definitely not an immune disorder. Fibromyalgia is something, a central pain disorder, but it's not an inflammatory disorder. Contrary to what you see in the literature. Immunophenotyping. We do an amazing immunophenotyping of cells now, and that led to the project, a cancer project we're doing right now. It's ongoing, and there are many different types of cancer, many different ways of applying PNI to cancer. But the one that intrigued me was what happens if somebody is, because of a type of cancer, in our case it's lymphoma, myeloma, has had their own immune system ablated for the treatment. They have to get rid of the person's immune system, and then they have to give them stem cells to rebuild this from scratch. To what extent does this field of PNI apply? To what extent does psychological state influence the capacity to rebuild an immune system from the beginning? That actually was a crossover from the fact that I began as a developmental researcher, and oh, this is kind of a development in a different point in your lifespan. So if you're not familiar with how this is done, if you have a cancer that involves your immune system, your lymphocytes, lymphoma, myeloma, what they will do is they will remove your own immune system regimen, and then they will give you stem cells, either your own or a related donor. And we're doing it both ways. We're studying this both with your own cells and donor cells. And this is which my thought process were. So you're here, you have to rebuild your immune system again from scratch, and our research project is let's study it sequentially. And immunity, so these little guys should come back first. They do, they come back in about 2 weeks. Then we should start to see natural killer cells. They come back in 3 weeks. Monocytes, they're actually predominant about 4 weeks. B cells take about 3 months to come back to the, and finally your T cells come back. And so that's what we're studying. Do they come back in the right order? Do they come back in the wrong order? Not so good for you. Do they come back in the right package? The original set point that they should be. And what's cool with this kind of flow stuff, you can actually study that. Same kind of thing. I'll go this is set up this immune-free pattern however you want. T cells as well. And the quick take-home message, all you need to do is look at the green bars here. If the people were very depressed and anxious on the day of the bone marrow transplant, that's when we assess, we can assess it later, and we follow it on day 30, day 100. There were only 39 in this graph over 100 now, same findings. The more depressed they were at the time of the transplant, the slower. It takes longer for their cells to come back. Conversely, on the happy side of the equation, now green and up is good. If on the day of the transplant, they, using this scale, said they felt they were getting support from their family, from the doctors and the nurses, same finding, but in reverse now. So on the positive side, the more integrated, the more support, the higher, the faster the cells come back. And this is clinical constant. The faster your cells come back, they can't get out of the hospital until their cells come back, so they only spend the first month. So it's a big deal to have your cells start.
What's the biological signal describing this? Those patients with post-social integration, slower or more depression, slower. What is this?
In my world, you would start with psychology. I put thought and emotion first, brain. You know, but then that would be satisfying to most of the biologists in the room. So then you start to come into mediators, soluble mediators, colony stimulating factor kinds of stuff. So there are equivalent cytokines whose job it is to stimulate cell proliferation, cell differentiation. So we were talking about multi-cytokine arrays. So with this, we don't just do immunophenotyping. We also take serum and we look at interleukin 12, interleukin 18, colony stimulating factor. Ones that presumably would account for quicker receptor. In truth, I don't know the answer to that. That's the kind of grant we write to try to get funding to study this. Speaking of which, I should just say, I didn't realize this when and I also should. The reason I can do so much of this kind of research in my stage is I do a lot of collaboration and the fact that this young woman is an assistant professor in those kinds of areas, who's the leader. And of course I couldn't do this without the MDs, oncologists, these two guys are oncologists. This is the crew that's the phenotype. And this is all collaborative research. I mean, this is modern science. Nobody can do it. Ooh, you left me 10 minutes. Can I keep going? I'll get to the last part, the maternal and child health. So in the animal research, I do some use in this area too, but more of this is done with monkeys, with primates. And I've pushed back a little bit from early rearing. I know you study early life events, but for me, I've gone back in utero to prenatal, to where it all began, and pretty much this page says it all. To how much is the fetus responding to the world, how vulnerable is it to events that mom experiences. So I do this in monkey models, or rhesus monkeys. This is one type of paradigm. Suppose mom, pregnant monkey, pregnant woman, gets a viral infection that causes an inflammatory response. Cytokines, does that affect the central function? Yes, it does. Can some cytokines cross? Yes, if they're high enough. IL-6 can cross. In turn, the baby receives this, reacts, and so the cytokines don't even have to cross, the baby starts making its own cytokines, almost in a harmonic. When mom makes it, the baby starts to make it, and bear in mind this is a baby without a blood-brain barrier, so those cytokines just go right to the brain. So this is one type of experiment we've done with influenza infection. You just take pregnant monkeys, they either get a sham infection or a flu infection. We're using a strain that was circulating a few years ago in Sydney. We infect her for a week, resolves, let the baby be born, study its brain development. We use the same crew you use, on science crew at UNC. This is actually monkey brain reconstructed after a scan. We look at the baby monkeys once they're born at a year of age, and as you can see, we gray matter, white matter, volumes, hippocampus, ventricles, and this says it all. And you give a flu infection to a pregnant monkey, let its baby be born, grow up a year of age. The scan here is minus. Controls, there's more than a 5% increase in volume, size, gray matter, white matter, just significant with RN, and as you can see, cortex was quite impacted. It's not at every point in pregnancy. We found there were more sensitive times when flu. This was a day 120, so about a month before birth. It has a pretty negative impact. And you know, flu infections are linked to schizophrenia, risk for ASD. Stress, we study stress effects. Stress has many effects on the fetal immune system and past, but I wanted to show you something a little bit more current. We've documented that if you take a monkey from a stressful pregnancy, its gut bacteria are different, good bacteria as well as bad bacteria. These are the good guys. These are what are in probiotics, bifidobacter, lactobacilli. They're stimulated by breast milk. They're also important to inhibit the growth of the bad ones, the inherent pathogens. And the take-home message is pretty simple. We were watching the development of the gut bacteria after birth. This is the first 24 weeks of life. It's a log scale, so these are actually fairly big differences. Come from a stressful pregnancy, early stress, late stress, and the good bacteria are going to be lower. We've altered the GI tract, we've altered the microbiome, and the consequence is you come from a stressful pregnancy and have altered good bacteria, you're going to be more prone to bad bacteria. Lower the lactobacilli, bifidobacter, and in monkey colonies, Shigella is one of the enteric pathogens of concern. This was late, they didn't actually have symptoms, but 40% of the ones from the stressful pregnancy we can detect Shigella, which is the cause of diarrhea in monkeys, and what's illustrated to my right is some of the ones from the late stress actually do develop diarrhea. They got Shigellosis. This is to get me to the modern age. Back then, when I did that study, well, I should credit Mike Bailey, we actually had to grow up the bacterial culture. We actually set up aside a couple of cultures. This is the way you do it. Today, I stopped doing this for a while, and I came back to it because pyrosines is so cool. So now you don't just measure one bacteria at a time. You send a swab out, and what you get back is the DNA profile of the entire gut. Lactobacilli is still here, Shigella is still here, but now this is what you get back. 200 bacterial genera from a single swab. It is so exciting. I'm out of time. Just say you can go through animals and profile them for types of bacteria. Lactobacilli are still the most predominant ones. These were the 15 genera that were over 1%. In truth, you have 1,000 species. We get back 200 genera at a time. I'm going to just jump to the end. So the take-home message is early life events, prenatal events, early rearing, as well as contemporaneous stress, non-stress, other types of positive and negative events, influence our brain. They also influence immunity. I believe they influence our overall health and well-being. And I think they're particularly relevant at 2 points in the lifespan, childhood and old age. And the clinicians are in the room. These aren't new ideas. This goes back to one of the important fathers of medicine, Osler, and he wrote, "It is much more important to know what sort of patient has a disease than what sort of disease a patient has." You say it a little strong, but I definitely think who we are influences whether we get sick or not, and progression, probably the place to stop. Thanks.